Okay, pre-calculus. We are on the second day of Unit 6, Law of Cosines. Law of Cosines is a little bit more tricky than the Law of Sines, so we only use it when we absolutely have to. Before we start, so here's kind of a summary of yesterday. So we use the Law of Sines when we have one side of a proportion, basically. When we have a side that's across from a given angle. Okay, in all three of those cases we worked on yesterday. However, we're going to do two cases today, SAS, side angle side, and side side side, where we don't have a pair. We've got this fabulous angle here, but we don't have any information across from it to write one side of a proportion. So in this case, we have to use the law of cosines. So here it is. Now it looks very similar to the Pythagorean theorem. And I know this ABC thing is confusing, but we'll get there. So, and just remember that in any triangle, the sum of the lengths of any two sides has to be greater than the remaining third side. So I always like to just keep that in mind. We don't have to really worry. I'm not going to give any problems you have to worry about that, but that's just good something to note. So we're going to do both types of triangles, the side angle side, I like to call SAS, the SAS triangle, and the side 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 triangle. So first step is we're going to use the law of cosines to find the third side. So in this example, and sometimes you have to draw the triangle, you take the information, it doesn't really matter what you put for A, B, and C as long as the lowercase a side is across from the A angle, okay? So I went ahead and just took that information that they gave us here and put it in a triangle just so I could get a visual. And I decided to go ahead and solve for the side that was across from the angle, which is here. Step number 1, use the law of cosines to find the third side, okay? So in doing that, I should have a pair, and if I wanted to after that, I could use the law of sines to continue on. However, it's probably best if you use the law of cosines because then you could end up getting your ambiguous case. That was from last class where you end up with two solutions. So it's better to just use the law of cosines here. So let me start here. Okay, so if I'm solving for C, we're just plugging the values in for this formula right here. C squared equals A squared plus B squared minus 2AB times the cosine of C. All you are doing is plugging in values, but you just have to be careful. You are using order of operations and you know how to do that. So just be careful and look at my work here and make sure you understand how to do order of operations. I think you'll get it if you just take a look at it. So the length of the missing side is in this problem, it's root 7. So once we have that, yes, in theory, we could use the law of sines because we then have a pair. However, it's best to continue with the law of cosines. So now all I have missing now are two angles, A and B. So I'm just going to start with B. And when you are isolating in a different color, if I'm going to choose to isolate, come on, why is this? There we go. This angle, I have to subtract this A squared from both sides, subtract this C squared from both sides, and then divide by this minus 2AC. If I'm just isolating just the cosine of B. So when I do that, if I isolate the cosine of B in this formula, this is what I get. And now I'm just going to plug in the values. When I do that, I end up with this. And now we have to find the measure of the angle. That involves inverse cosine. So we take the inverse cosine. So on the calculator, it would be inverse cosine of -2 over, it's a negative over a negative, so that's a positive. I'm just going to, the way I'm writing it here, 2 over 4 root 7. Be careful anytime you put multiple things in the denominator. If you're typing in a calculator sideways and not vertically, that's 2 divided by parentheses 4 root 7, close parentheses. Be careful about that. If you're using the numerator over denominator button on the TI-84, then it will give you the fraction so you can put both of those values under the vinculum, which is the fraction or the bar. Okay, so once we use use inverse trig and find the measure of the angle, then we have two angles. We can subtract those, the 60 and the measure of angle B from 180, because all three interior angles have to add up to 180, and then we get the value for the measure of angle A. Okay, I'm trying to keep this video down to just 15 minutes. So the next type example that we're going to use law of cosines for is side, side, side. So again, we don't have a pair, so we have to solve for three angles. So we're going to use the law of cosines to solve for two of them, and then we're going to subtract those two angles from 180 to get the missing angle. So it doesn't really matter which one you started with. I just said, all right, I'm just going to solve for the measure of angle A. So if I'm isolating in this first equation here, measure of angle A, that's going to be a squared minus b squared minus c squared divided by negative 2bc. That's where this comes from. Then we take all those values, we plug them in, and we do the inverse cosine of 29 over 36. For the measure of angle B, we use the second formula. We isolate cosine of B, plug the values in. You should get this, and you might have to press pause to make sure you do get that. And then you do the inverse cosine of 43 over 48. Once you get those values, okay, and we're dealing in degrees here, then you can subtract those two numbers from 180 to get the missing angle C. Here's a you try. If you would like to try it, you may. I'll leave this up for just a second. Okay. Okay, and sometimes you might get a word problem. So a motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents. So the crew finds that after 4 hours, the sailboat is off course by 20 degrees. So they've got a diagram here, and I went and redrew the diagram over here just in a triangle, just so I like doing that myself. But where they got this 60 from is they're going 15 miles per hour, and they went for 4 hours before they changed their course. So that's 60 miles. So now if I look at what's missing here, what we're asked to find is how far from Key West is the sailboat. So we're asked to find, here's the sailboat, right? And this is Key West. So we need to find that distance. Well, that's C on my triangle over here. And so I'm going to go ahead and use my formula for the law of cosines. A squared plus b squared minus 2ab times the cosine of c. Take those values, plug them into the equation. If you do it properly, you should get this value. Take the square root, and you should get 95.84 miles. Now, the next question says, through what angle should the boat turn and correct its course? Well, that's the measure of angle A. However, let's solve for angle A first by using the law of cosines. So we plug the values in, and we get the measure of angle A. However, the question is asking not for angle A. It's asking for, where is it? Through what angle should the boat turn and correct its course? So it's actually asking for this angle right here. Because it's going this direction, and now it wants to go this direction. Or we need to go get it over to Key West. So that angle is actually the supplement of angle A. Because if you have a straight line, here's angle A, we need this angle. 180 minus angle A gives us the answer. So that is 32.36 degrees. And the last part, sometimes I skip this part, but it's not bad for you to see. I wouldn't put this on a test or anything, but so how much time has been added to the trip because of this, assuming that they're going to remain on course and continue the same speed? Well, the total distance that they actually went was B plus C, so that's 155.84 miles. At 15 miles an hour, that's a total of over 10 hours, okay? So the original trip should have taken 10 hours because they were only supposed to go 150 miles, that same speed. So it actually takes 0.39 hours longer, so it's 23.4 minutes to make this trip, which I guess isn't too bad. All right, I think that is it. All right, peace out. Oh, short. Yay.